Hello and welcome back to another show of From the Field. I'm your host, Casey Orr. I'm in Wellington, New Zealand. We've got an amazing topic today. We're talking about resilience, which is something that we've talked about a lot internally and is something that has definitely changed my perceptions on a lot of things. So it actually is a really great topic, even though it seems like kind of boring on the surface. I can assure you it is not. There's lots of different layers to it, so to speak. And we got Mark, Nicola, and Imran here that are absolutely experts in this field and have an amazing presentation built up for you. Just some things for everyone to know. So we do have a special from the field show happening at 7 p.m. New Zealand time. So that is in 8 hours now, relative to whatever time zone you're in. And that is going to have one of our serverless advocates and one of our local SAs, Debica. And while I will be moderating, I will not be the host for that one. That'll be Trevor, return of the silver fox, so to speak. And that is going to be an amazing show. So if you want to learn about more about serverless and all of the wonderful things that's happening there, and hopefully it's not midnight, even though I think last time we had a person watching us like 2 a.m. in Switzerland, I think it was, or Sweden. Oh, hopefully I didn't get that wrong, because I know that those two countries don't like it when you mix them up. And so talking about resilience, I actually do have an interesting backstory on this one. Back when I worked for my start, we had a resilience coach come in, and I was talking about the different 7 layers of resilience going through your personal journey, and how like it's kind of like a spiral, and you have to just sit back, do meditation, relax, reflect, and all of that, and make sure that you're not going to continue down the spiral, so to speak, and actually work your way up. At the time, it was absolutely boring. I'm like, why am I doing this? I think throughout my professional career, it's actually probably one of the few trainings that has helped me the most. So I'm hoping that this talk is going to be as great as that. And on that note, I'm going to pass off to Imran that will do introductions about what we're going to cover. And he is also a very brave man, because it looks like he's running off his mobile internet. So over to you, Imran.
Hello, everyone, and yes, fingers crossed, hopefully everything goes well. So today we have a really special topic, right? Resiliency, that we've been, as Casey mentioned, talking about that quite a bit internally at AWS. And, everyone's got a different concepts and definitions of resiliency, and resiliency plays quite a big role at different parts of your architectures when you're talking about your workloads. But I thought it would be a really good idea to talk about how AWS views resiliency within our services, and how we describe the concepts, and how do we design our services. And for that, we'll be going through that, the basic concepts. And at the same time, I wanted to bring in local zones, which have recently launched in Auckland, New Zealand. So wanted to talk about that as well, and try to see how resiliency plays a part in there, and how do we design our local zones to be as resilient as possible, given that they are a single geographic location itself. So yeah, we'll kick off with that. I'll pass you back on to Casey, who will then introduce our next speaker.
Yeah, great. And the resilience topic with local zone is one that you won't see. So this is very much a topic that, if you do watch the stream, you will be like one of the few experts in the world, so to speak, outside of AWS. So that is going to be awesome. So Mark, why don't you give yourself a quick introduction?
Yeah, thanks, Casey, and thanks for having me. So my name's Mark Jones. I'm an AWS solution architect, Australia-based, who is coming out of Melbourne. So as well as being a solution architect dealing with digital natives in Australia, so born in the cloud customers, I'm also considered a deep resiliency specialist. So I work with customers every day to talk about resiliency. I don't think it's boring. I think it's a really interesting topic. And I guess what I'd say, it's boring until you get it wrong, is what I would say. And these days we're having more and more conversations, which is absolutely fantastic. I do think that the two subjects go really well together. So resiliency and local zones, because there are lots of concepts that need to be applied when you're considering local zones for your workload, and also how to apply and use local zones as well. So look, what I'll look to do today is I got a few slides to talk about some concepts, but we can kind of take it wherever it needs to go. Happy to take questions, and keep it, basically go where we need to go on the subjects. But we will go through a couple of slides just to kind of baseline, talk about resilience, why it's important, and not boring. and just to really kind of go through some of those concepts, if that makes sense.
Why don't I kick you off with a question then? What is resilience? We have a lot of concepts like high availability and DR. Like, what's the difference between the two? You have control plane versus data plane, and you have like fault isolation barriers. Like, what does that all mean?
And static stability. I mean, there's lots of these core subjects or concepts that we combine to deal with all sorts of questions and also architectural decisions as well. So look, happy to kind of take through and we'll walk through a couple of slides. But then, as I said, we can get stuck into local zones and maybe talk about how those concepts actually apply to local zones as well, if that makes sense. So what I might do is just quickly go through and just start with, I guess, why we're having more and more conversations around resilience these days. Because, as I said, it is really an emerging topic. And, we've been thinking about this for a long time, but from a customer perspective and also from AWS perspective, as I said, we're having more and more conversations. And I think it's primarily because we're dealing with unparalleled times, like very unique times in the software industry. We've never seen any times like it. The appetite for innovation, both from end users and also our internal stakeholders has never been bigger. And luckily, like, the tools for innovation have never been better as well. I mean, there's been no better time to really be in the software industry. But adding to this, like, the accessibility of cloud and faster networking, except if you're in run using public networking, has led to the development of these really highly distributed and basically sophisticated system architectures. Like, complexity is just going through the roof, with more and more dependencies being incorporated into services all the time. The expectation is that we're all delivering smaller changes faster as well. And with the rate of change always accelerating, like, let's face it, with every change comes an element of risk. And all this in a time where customer tolerance for failure is actually decreasing. So it's no longer acceptable to be down even in the face of failure. I mean, I can remember, prior to AWS, I was leading kind of software delivery teams, and it was quite acceptable to have a couple of maintenance windows every week and to take systems down, but those times are really behind us. I know that a lot of, like, through the conversation I have with customers, that these kinds of things resonate, but it's also the world that we at AWS operate in every day as well, right? So, I mean, we're delivering features faster than ever and services faster than ever, and internal and customer expectations have never been higher. So as an organization, AWS has had to learn a thing or two over the previous years about service resilience in the face of failure. Sorry, slide's not responding. And one of the most significant things we've learned is around, like, the mindset or approach required to build and operate those truly resilient, complex distributed systems at scale. I'm sure you've all seen the quote, and Casey, I mean, we've seen it millions of times, right, through AWS presentations from, like, Amazon CTO Werner Vogels, where he says everything fails all the time. And me personally, I thought, geez, it sounds rather bleak. But I mean, Werner was in town not that long ago, and through conversations, I mean, what he really means is that we hope for the best but plan for the worst. So we assume that everything fails all the time. And in the 16 years or so that AWS has been operating, we've certainly seen things fail in the most spectacular ways, in ways that we couldn't possibly have thought, anticipated. But like, throughout it all, this mindset has certainly served us well. So it's allowed us to anticipate and design for a wide variety of failures. And even when things don't go well and we've been unable to anticipate a failure, it's really helped us learn from the failures and ensure they never happen again. And, basically, as builders, I mean, we've got loads of different failure types that we need to think about, ranging from the more frequent issues like bad deployments on the left, and quietly, I mean, this is the one that I see as the number one risk with customers and ourselves as well. Let's be clear. Right through to the highly unlikely scenarios on the right. So, of course, these are really unlikely to occur, but some customers still need to consider and plan for them, right? If you've got a workload that needs to be extremely highly available. But before we do go much further, I think it's worth just quickly taking a step back and really level setting on the term resilience, right, and what it actually means. Resilience refers to the ability for workload, so a collection of resources and code that delivers business value, such as like a customer-facing application or even a back-end process to respond and quickly recover from failures. And the mental model we use internally, and that I guess I want all of the viewers to really consider, is the following three things, right? So how you can build systems to be highly available with resistance to common failure modes, how you can recover your system if you run into those rare failure scenarios we saw on the right of the previous slide, and finally, this notion of continuous improvement. Resilience, importantly, is not a one-time thing that you check off your list. I mean, we've done it, we're a step away. I mean, continuous improvement entails things like anticipating failure at design time, implementing sound DevOps practices, introducing failures on an ongoing basis to test your systems and teams for weaknesses like chaos engineering or tabletop exercises, game days, implementing ongoing observability and monitoring practices, and learning from failures through post-incident reviews, most customers call it, or at Amazon, we call it like a COE or a cause of errors process. So let's go a bit deeper on both high availability and disaster recovery, because these are the terms that customers can confuse or misunderstand. High availability is focused on preventing loss of service due to anticipated failure modes. It's generally measured by the amount of time that an application is able to remain available and fulfill its intended business function. So for high availability, both goals and performance are generally measured as mean over time. So like how many nines? So 99.99 available as is on the slide. When we talk about disaster recovery, it's all about business continuity in the face of a failure that we couldn't prevent. So any event that prevents an application from fulfilling its business objectives in its primary deployed location, well, it's a mouthful, can be considered a disaster. But we typically associate DR with larger events like natural disasters like earthquakes or floods, technical failures like power failures or network connectivity, human actions such as misconfiguration, or even in some cases, bad actors. We generally define our recoverability requirements and measure the performance of our recovery by recovery point objective, or our RPO, which is the tolerable amount of data losses a unit of time. And most customers will say that needs to be as low as possible, right? And recovery time objective, or RTO, right? Which is how long it takes to become operational again. A DR strategy can be as simple as a backup and restore process, right through to, in some extreme and rare situations, like active-active. And it's generally dictated by business requirements. So now that I've spent a little bit of time kind of defining those HR and DR concepts, I just want to quickly discuss a couple of other concepts that you touched on before that I think are critically important to consider when thinking about local zones, right? So they're fault isolation boundaries, even our AWS infrastructure design at a high level, control planes, data planes, and static stability. So to start with fault isolation boundaries, and this is critically important. So a fault isolation boundary limits the effect of a failure within a workload to a limited number of components. And you may ask, like, why is this important? Well, components outside of the boundary remain unaffected, allowing you to avoid correlated failures and remain available and serving requests even when issues are encountered. And it's a pretty good outcome, right? When you think about it, though, this is not a new thing. I mean, we've been wrapping code blocks in try-catch statements for years. It's just the scale that it's applied to that's a little bit different. So let's make it real and explore some specific fault isolation boundaries that exist within AWS and talk about how you can better leverage them in your systems today.
Just one quick question, Mark. Well, just
fire.
sprang to mind, which is would the same concepts around fault isolation boundaries be true for how you would interact with third-party services like APIs?
100%. So not only a fault isolation boundary, we consider obviously AWS services as dependencies, but we also think about, any place where we're transitioning, right? So we're basically handing off, right? So third-party services are a great example of that.
Awesome.
I'm sure everyone has seen this diagram or similar. So, it's effectively talking about how AWS builds and deploys our global infrastructure. I want to quickly have a look at it briefly in the context of resilience and more specifically those fault isolation boundaries that we just talked about. So with the launch of the new Melbourne region, we've now got 31 regions around the world, which is staggering. Regions are separated to contain service failures, meaning that when service impairments do occur, other regions are typically unaffected for their normal operations. And this is super important, right? Each AWS region consists of 3 or more independent and physically separate availability zones, or AZs, within a geographic area. The AZs in an AWS region are interconnected, right, with high bandwidth, low latency network, and they're over fully redundant, dedicated metro fiber, providing like the high throughput, low latency network that we need. Each availability zone in a region is separated by a meaningful distance from the others to prevent those correlated failures we talked about before, but at the same time are close enough to still support synchronous replication. They're designed to avoid being simultaneously impacted by like a shared fate scenario. So when I think shared fate scenarios, I think like power, water distribution, fiber isolation, earthquakes, fires, tornadoes, and floods. Common points of failure like generators and cooling equipment are not shared across availability zones, and they're designed to be supplied by independent power substations as well. Importantly, like regions, availability zones are designed to minimize the blast radius of failures, meaning that issues that occur at the availability zone level in one AZ typically don't impact other AZs. Finally, each AZ is made up of 1 or more discrete data centers, and each of these have independent and redundant power infrastructure, networking, and connectivity. So the concept of fault isolation boundaries also applies to the way that we design our services as well, right? So the terms control plane and data plane like originated in the world of networking, specifically routers. But what do routers do? I mean, routers are effectively just serving packets in and out all day. I mean, that's the data plane. But the rules have to come from somewhere. They have to be created and distributed, and that's the job of the control plane. Applying the same pattern to our own service design, AWS engineering teams strive for the same separation of concern. So they're effectively carving up our services into control planes and data planes. The control plane for AWS services typically include operations that create, delete, list, and describe resources. So these operations are often complex with more dependencies, and as a result, more that can go wrong. Whilst the data plane is the day-to-day operational resources, right? So they should be simple and dependable. As a customer, this is important to understand because control plane and data plane operations have very, very different design priorities and should be thought about very differently when being considered as a dependency. So you can see, a control plane is really prioritizes consistency over everything else. And obviously data plane is prioritizing availability. So here are some examples of the separation between control plane and data planes across a couple of different AWS services. I'd suggest the most clear-cut example to focus on in this list here is DynamoDB. So the control plane operations are responsible for creating or updating your table, whereas the highly available data plane operations are leveraged for reading and writing data in the table itself. So to further explain, I think it's worth having a look at a concrete example. So I like to talk about EC2. It's really clear cut. So, and just take note of the animations. I mean, this is some of my finest work. But here we have 2 EC2 instances that are communicating back and forwards. This is the data plane of EC2. If I was to call run instances to get a new EC2 instance, I make the API call, and in a few seconds, a new instance starts. But in that time, loads of complex work has to go on behind the scenes. So if you think about it, you need to find capacity and availability zone. You've got to create and attach EBS volumes, create short-lived IAM credentials, allocate network addresses, update internal DNS, even distributed networking rules, etc. And that's all done by the control plane. And now finally, we have 3 EC2 instances all sending data back and forth. But why is this important? Well, basically, how will it keep your services available? I mean, the idea behind it is static stability. So static stability is a really important concept in the field of resilience. And static stability means that a system can operate in a static state and continue to operate as normal without the need to make changes during a failure or unavailability of a dependency, whether it's ours or like you talked about before, Casey, a third-party dependency. What I really like is the more simple definition. So static stability means having dependencies, and let's face it, most systems do, but not sharing their fate. And this concept equally applies to both, our service dependencies and any other type, as we talked about before. But why is this important? Well, service control planes and data planes are themselves a type of fault isolation boundary, helping to maximize service availability for customers. And when failures do occur, because AWS service data plane operations strive for static stability, in most cases, an impaired control plane will not have a negative impact on the data plane if the workload is truly statically stable. So returning back to our previous example on EC2, take the EC2 data plane, instances running on physical servers. The physical servers have some software on them storing state for things like the VPC, mappings to reach other instances, etc. In the face of a control plane impairment, the physical hosts continue to operate and could even reboot and still carry on running your EC2 instances like nothing has gone on. Of course, in this same example, control plane operations like EC2 run instances would fail to execute, but the day-to-day operation of the resource deployed, so running the EC2 and serving those requests to your customers, just continue on. So look, I've kind of covered most of the resilience concepts I was going to cover this morning, Casey. So maybe, Nicola, if you want to come on, introduce yourself, and maybe you can go on.
Before you go on, Mark, just a quick question around that.
Yeah.
I mean, you shared the data plane and the control plane and described it beautifully. Now, example that you gave us around EC2 services, but how do some of our global services like the Route 53 and IAM map to the same concept of data plane and control plane, especially when you're looking at the fault isolation boundaries of our regions, because they, from my understanding, is not regional services, are they?
Yeah, and look, that's a great question, right? And one that we commonly get from customers as well. So exactly the same concepts. The distribution of our control plane and data plane change, however. So let's use IAM as an example, right? So IAM is a really great example where we've got basically a centralized global control plane, which is US East 1, right? So when we make changes, when we create new roles, when we manipulate roles, as an example, those operations are being run against our control plane, which resides in US East 1. The changes that you make actually propagate, they're eventually consistent down to every single region globally, right? So the data plane for IAM actually exists in every single AWS region, right, within a partition. And so it's a great example of static stability. So when you make a change with the control plane, those changes are replicated down to each of our regions, and the data plane within each of those regions are statically stable. So if for whatever reason IAM is not available, you can still authorize, you can still basically act, through all the control plane operations. It's just changes basically won't take effect. Does that make sense?
No, that's really, really good answer. And I think in terms of the IAM specifically, so things like getting temporary credentials, I would imagine that is a data plane function, right? So you don't.
It is, yeah, correct. But a gotcha is we have both global and regional endpoints for STS. So one thing to take note of is, as customers, make sure you're using the regional STS endpoints, because that means that you're not basically making those calls against US East 1. You'll be making those calls against the region, in which your workload resides.
And a number of our services have regional and global endpoints, right? It's not from memory.
Yeah, absolutely. Absolutely. So the big ones that we always talk about are like IAM, Route 53. There are a number of our global services that basically are architected exactly the same way. And these days, control planes, like the global control planes, are not just US East 1 as well. They're being basically moved or deployed across a number of different regions as well. So the days where everything's going to US East 1 for global control planes kind of changing. We're diversifying a little bit.
Nice. So thank you, Mark, for your great summary around resiliency and everything like that. And if you have any questions, viewers that joined towards the end of his talk, do feel free to ask questions, and we can go over any of the topics that you missed out. In the meantime, Nicola, do you want to introduce yourself and then actually let us explore the wonderful world of local zones?
Sure, not a problem. Hello, everyone. Thanks for joining today. My name is Anikola Chucha, and I am ANZ go-to-market specialist looking after the AWS hybrid products. AWS hybrid products include a local zone, outpost service, and the Snow family products. Now, just before we start, regarding on the local zones, I just wanted to touch base on the some of the customer feedbacks that we have received and the reason why we have developed the products such as the local zones. So local zones came out of a request from the customers, which really wanted to bring the cloud closer to them. They usually have applications that have a latency requirements, or in some cases in the two-step migration, it was too hard to do a lift and shift to the region, and the local zone was the answer to bring the cloud closer to the customers. Also, over the years, we have heard the feedback that the customers, they enjoy using the cloud, they love the API, and it would be a great idea to use these same APIs, the same services as they do in the region closer to them. Also, some of the customers are looking into trying to exit the on-prem data centers, and we're looking into the more managed service model. So out of those feedback, we have developed the product which is called AWS local zones, which are type of the infrastructure that we have launched to address hybrid cloud and edge customer needs. Local zones, what do? They bring compute, storage, networking, and database closer to the customer. On-premise data center, or the source of the customer data. Most of the use cases, or most of the workloads will be you will be able to serve them out of the Sydney region. However, there are some instances, and there are really two group of the use cases that we are seeing that are very popular with the customers. One fall into what we called a latency-driven a pillar, which is the application or the workloads that require the quick response time. So one of the probably the most popular ones we are seeing in the real-time and gaming industry. The other one would be the artist and content creation type of the workloads. And then there is the second pillar of the use cases, which we call under the data residency umbrella, which means that the customers, we need to run the workloads or the application in the certain geographical area. Now, local zones, and what do they offer is they would offer the a compute, storage, and a networking services, and the local zone it's connected to the region. Why do customers like to use the local zones? They, first of all, probably the number one feedback that we have heard, they enjoyed using the same APIs as they do in the region. So that means they have developed the cloud formation templates, and they can easily expand them or deploy them in the local zones. The other one that is also becoming a very popular is the local zones. They offer same as the region pay as you go model. So you only consume the compute and storage and networking services for duration of the time that you need. Also, with the local zones, you can extend your VPC. You can extend and deploy and create the subnets, and it's as simple as deploying the workload in the subnet. The other one is the speed of a deployment that we are also hearing back, because at the moment the customers, they need to develop and test interoperability in the region, and then they have to take the same workloads and do the same interoperability with the various type of the hardware and the software from the different vendors on-prem, and that tends to generate quite a lot of overhead. In the other essence is that with the local zones, because we are using the same infrastructure as in the region, we are using the same API. So they would develop and test once and deploy to the multiple sites. The other one is the local zones, same as the region. We will follow the same rate of the deployment of new features and the functionality, and that improves speed to the market. The other one that is is it unblocks that what we call the last mile of the on-prem application, and so far we're seeing across ANZ that the probably what we called a monolithic application and two-step migration, where the customer would move the front end or the back end to the nearby local zones and slowly start to modernize and containerize a monolithic workloads. If we can go to the another slide, please, Mark. So in the essence, local zones type of the infrastructure similar to the AZ. It's managed by the AWS. It's got elastic on-demand resources, follows pay-as-you-go a model, and you can find the same type of the services as you do in the region: ECS, EKS, EBS, ALB, and DX. If we can move to the next slide, please, Mark. So what is happening across ANZ or Australia and New Zealand? So to date, we have deployed 2 local zones. Once it's in the Perth, the other one is in Auckland, and there are plans in FY24 to we will be launching a Brisbane local zones. So in addition to a Melbourne region across the ANZ, we have 4 points of where the customers can connect and consume AWS hybrid services. Perth local zones was launched in January, and to date, the most interesting use cases we are seeing VDI, virtual desktop, where the customers are running graphic intensive workloads. And the benefit of that, they have shorter the sub 10 milliseconds latency, and that improves the customer experience as well as the response time. The other aspects that the customers are considering the local zones, which I'm sure it's a part of the resiliency story, is that to incorporate the local zones in a resilient and a redundant architecture with failovers. That's pretty much it. Are there any questions? So in terms of the services, the local zones will obviously offer the subset of the services that we can find in the region, but what you're seeing the combination of compute, storage, networking, and the database. We are always looking for additional feedback or additional services that the customers would like to see. So if you have any comments or any questions where what we could include in the local zone, that would be very much appreciated.
Awesome. Thank you for that great summary there. And yeah, the reducing that latency for those graphical applications and stuff like that is really important, because there's nothing more annoying than trying to actually use an application and you click and like 5 seconds later like the menu appears. We've all experienced that.
Yep, definitely.
So I guess now, Imran, it's over to you to bring this all together. So we've learned about resiliency, we've learned about local zones, and yes, so row 101, yes, there is going to be a demo of a local zone I believe Imran can give us a quick summary of what he's going to be showing just in a sec, but he's going to bring together the resiliency and the local zone aspects as well and explore why a local zone is more resilient than an existing local data center. Over to you.
Awesome. Thank you, Casey. Mark, could you get to the next slide, please? Right. So I thought, as Casey mentioned, sorry.
Before you dive into it, can you go over quickly what the demo is going to consist of?
Sure, definitely. So look, just quickly talk about the resiliency and the local zones. And one of the few points that I wanted to talk about was why local zones or your workloads can be more resilient in local zones. Number one is around the purposefully designed hardware. So Mark, if you next slide. So if you are aware of AWS and how we design our hardware, it's the same physical hardware that we run in our regions and availability zones, which is run in a local zone. And one of the biggest differentiators that we have come across over the years and developed is the use of Nitro cards, or actually having a Nitro hypervisor in our physical host itself. So if you think about the traditional virtualization, most of the virtualization technologies will actually make use of the existing CPU storage and memory and everything else on a physical hardware to actually provide the virtualization back to the guests. So what we have done is we have extracted out some of those functions as a separate dedicated cards that we call Nitro cards, and which allow us to offload some of the IO performance to those cards. So for example, if you think about networking, which can be quite complicated and take up a lot of resources of the actual physical hardware when you are providing virtualization back to the guest. So think about, if you're providing 10 gigabit links back to the guest running on a virtualized hardware, it can take up a lot of resources from that hardware. So what we have done is we have taken that out and put that on dedicated network cards. So same with the EBS and as well as some of the security functions, which allow us to actually make the most use of the CPU and memory provided by the physical hardware back to the guest rather than using it for these functions. Another advantage that we have with this is that it provides us functions like encrypting our EBS volumes. The actual virtualization layer is not spending any more resources to encrypt or decrypt the data that is happening outside that in our Nitro cards. And sort of going back to the whole control plane and data plane, what Mark mentioned as well. So we do have EC2 control plane, which for the specific for local zone runs out of the region. And then we use that to provision the resources in the local zone. That's where the data plane runs itself. So that's about that. Do you want to move to next one, Mark? Cool. The second one is around the networking backbone and the access to the region. So if you have other workloads running in other regions in AWS, or you are consuming workloads from partners or other customers who are running workloads in AWS, they can make use of that backbone and redundant networking that we link up with our local zones. So the next slide. Just a quick view of how that redundant networking is provided if we specifically look at New Zealand itself, back to Australia region, as well as to the rest of the regions worldwide. So you can really take advantage of that when you're running workloads in local zone to have a high speed and redundant access to the rest of the world. Next one, Mark. And the last one is the ability to use placement groups. I think one of the things we don't talk about enough is, even though local zone is one physical location, it has obviously multiple racks and multiple hosts that we provide back to the customers. And if you want to make sure that your workloads have as high availability as possible and as resilient as it can be in a local zone, is to make use of the placement groups. And I'll talk about the placement groups in the demo, is what they are and how you can increase the resilience and availability of your workloads using that. So again, that's another feature of local zone which you can take advantage of. Next one, Mark. Cool. Just lastly, around the redundancy for the local zones. Again, this is something that we don't talk about enough, I think, is that the AWS local zones have the same, have redundant power and cooling as AWS data center standards. And they're also connected to the parent region using Amazon's redundant and very high bandwidth private network. And yes, placement groups are available in LZ to spread your workloads. Cool. So now I will take over and we'll talk about something which Nicola has gone through before anyway, but I'll show you as part of my demo on how do you actually use the local zones when you're deploying your workloads. So, share screen.
And now we get to see whether or not your mobile internet can support screencasting and your video.
Cool. So let me know if you guys can see that.
We can see your desktop. Now we can see your console. Do you
Awesome.
want to maximize
Okay.
Sweet. And if you can, just increase the size of the text to like 120%. Actually, if you click the three little drop downs, yeah.
How's that?
Yeah. That'll make it easier
Great.
for our viewers. Awesome.
Right. So in terms of the first step that you do when you come in to use local zones is you go to your EC2 console, like as you would. And on the right-hand side, you will see some settings that you can change within the EC2 console. And that's where you go and enable additional zones. So I've already enabled, as you can see, the local zones for New Zealand, Auckland, maybe Southeast 2, AKL1. I also have Perth enabled, but that's where you would go and enable different zones.
When you enable a zone, you actually fill out a form, correct?
Nicola, I don't think I had to do that. Maybe that's because I'm using one of our.
No, we don't have to do any form. You can just click on the manage button and then enable. Then it's simple as that. It takes a couple of minutes to go through.
Awesome.
So there isn't any long process to go through from that perspective.
It's a pretty similar process for our new Melbourne region as well, which is an opt-in region. So similarly, you basically just enable the region and up she pops and it's available.
So before I get into the actual instances, I think the main thing I wanted to highlight and show was around the placement groups. So if you guys are not aware of placement groups and what it allows you to do is, so there are 3 different settings that you can put in placement groups. The idea of placement groups is either combine groups of, I guess, servers or instances together or spread them out based on your requirements. So there are 3 settings that you can set in there. One is clustering. So it means you can cluster and confirm, or I guess dictate how the instances are running in an availability zone or in a local zone, right? So that means for high performance computing applications, you would want those instances to be running as close to each other as possible so that you can take advantage of that low latency, high networking between them. And that's where you will choose a clustering type placement group. Partitioning is where you will have logical partitions of different instances. So you would want to create, for example, part of your application instances would be partitioned in one logical grouping, and the another one would be another one. And the third one is around spreading, which means that any instances which are part of that placement group would be run on different physical racks and hardware. And the way you do is you would go into placement groups, you will create a placement group. So I've already created one, and then you would choose the strategy that you would want to use that for that placement groups. And when you go to launch the instances, I have a couple of instances running. As you can see, they are running in availability zone of AKL1A. And if I go to the properties of those, what I've done is put them into under host and placement groups. They are put into that specific placement groups, means then we guarantee that they would be running. So both of them, they use the same placement groups. I mean, they would both be running on different physical racks themselves. Cool. So that's pretty much it from my end. So there's
on placement groups. I'm not entirely sure if you know this off the top of your head, but if there's not enough capacity to, have everything as clustered as possible, because you want 100 servers or something like that, or 1,000, what would the behavior be? Would that result in an error, or would you just try to spin up as many servers as possible to fit that placement?
That's a great question. I haven't come across that, but I would imagine it would be some kind of feedback from our API EC2 control plane coming back and saying that there isn't enough physical racks available to, place your instances in those. Nicola or Mark, do you guys know that by any chance, or care to comment on that?
Yeah, so local zones, they do have limited relatively capacity compared to the region. So we would urge, if you have the customers that are requiring large number of instances, to reach out to us or to your account team so we can do necessary capacity reservation requests for the large migrations.
The reason I asked this is because one of my customers was gaming industry, and they went from having or requiring 5 servers to 600 of a specific family type. But obviously, created some fun.
Yeah,
it's a great question though. I don't know. It's worth kind of digging deeper. But I think what Imran said is probably right, in that we would provide, if we couldn't fulfill that and meet the requirements that are dictated in the placement group, my expectation would be that we would let you know about it. But I think it's a great question.
Yeah, I mean, very, very few customers who would have tested the limits of our capacity, to be honest. One of them I know in New Zealand, a media company, very famous one, which did test the limits of our Sydney region, and that's Weta, while they were, making that movie last year. But apart from that, I mean, there are very, very few companies who would actually go and limit the test the limits of our actual physical hardware. But as Nicola said, I think local zones obviously have a smaller capacity. So if you do have a customer who does require that larger capacity, please ping us beforehand so that we can ensure that there is enough available for them.
Yeah, the key message is really just come to us with your issues, and as the account team and the specialists in AWS, it's our job to really find the solution and fix it. So that's why I always tell my customers, come to me with problems. If you come to me with solutions, then I don't really need to be here, because I'm just kind of parroting what you already know. And with that, if you have any questions, do ask it now. This is your time to ask. If anyone's saying they're furiously typing on the keyboard, I'm just going to do a little bit of housekeeping. As mentioned before, we do have a special that is airing in 7 hours, so 7 p.m. New Zealand time now, and so 7 hours to whatever relative to your time zone, and that is going to be with a specialist visualist on our side, and they're going to deep dive into all of the new and cool features that we just released, and that is going to be an awesome show. That is going to be hosted by the Silver Fox Trevor. I will be around, but in chat. So definitely, if it's not 2 a.m., make sure you make some time to actually go and do that. In the meantime, Mark, Nicola, and Imran, thank you so much for making time to actually share your knowledge.
That's been awesome. Thanks for having us.
Thank you, guys.
Thank you, and I don't see any comments or messaging that's come through. So with that, I will say thank you very much for our viewers for taking the time out of your day and asking. I will say thank you very much, Row0101, to asking the only question. We deserve a middle star right there. Silver star, gold star. God, I am sick, and you could probably hear it. With that, I will say thank you, everyone, and with that, Marty, what?